So, good afternoon. Okay, my name is Junior Ramos, and I'm presenting the data communication and networking. Okay, so now we have our discussion for today. We have three parts of discussion, which is networking and fundamentals, network types and topologies, network models. Okay, we have networking fundamentals, number one. So our objectives are identify the network components, define what computers network are, identify the standard representation for network devices, and the last one is identify application that use a network. Computer network. A computer network is a set of computers connected together for the purpose of sharing resources. So we have components of the network. We have end devices, which is the hard components, and then intermediary devices. End devices, these are the computing device that interconnects with which has an IP address that is unique for everything for every computing device such as laptops, personal computers, printers, workstation, smartphones, IP cameras, and etc. So we have intermediary device. These devices provide connectivity to the network, connect individual networks, and connect segments within the same network. These are the commonly used network devices. One is, this is the internet hub, switches, router, network card, and the modems. So representation of network devices or components. This is the common data network symbols. This is the symbols of router, LAN switch, LAN hub, server, desktop, computer, laptop, firewalls, IP phone, wireless access point, wireless router, and WAN media and LAN media, and we have wireless media. So we have category of network components. Network devices are divided into three categories. One is end devices. Second is network infrastructure devices. And then the third one is network media. End devices, these devices are usually the destination devices in a computer network. These are the example: computers, handheld devices, printers, and camera. The second one, which is network and structure devices. These are the components of a network that is either software or a hardware which allowed connectivity among devices on a network. So the examples are switches, routers, and firewall. The third one, which is the network media, these are the cabling that enables connection between the different devices on a network. The example is copper, fiber optic, wireless. Application that use a network. The following are some of the net applications of a computer network: games, database, email, video conference, and PTC, which is file transfer protocol. So these are the first one. And then we have the second discussion, which is networking types and topologies. So objectives, these are the three basic types of network: LAN, MAN, and WAN. Describe the server client model. Explain the different network topologies. Identify the different network protocols and communication. Okay, let's start to local area network, which is what you call in short LAN. Local area network. This is an individual network that is usually spans a single geographic area, providing services and application to people within a common organizational structure. So as you can see, so these are the picture. Okay, we have now is metropolitan area network. That's what you call MAN. A man usually interconnects a number of LANs using a high-capacity backbone technology such as fiber optical links and provides uplink services to WANs and the internet. So as you can see, this is the modeling or the logo of the man. The third one is wide area network. One, wide area network, a network connection between two or more LAN over a potentially large geographic systems. See, as you can see in the picture, so this is a big connection. Okay, we have client-server model. The relations between clients and server is also known as the client-server model. So, so this is the internet, and this is the client and the server. So once the client asks for some website, so the server will proceed to generate and return back to the client. So the middle is the internet. Okay, now we have network topology. A network topology design is the arrangement of the computers in a network. Types of network and topologies. We have bus topology, ring topology, and star topology. So later on, I will show you the example of bus topology, ring topology, and star topology in the packet tracer. Okay, so bus topology is a network topology which every sorry every computer and network device is connected to a single cable. So this is the example of bus topology. Now we have ring topology. So this is a topology that forms a ring as each computer is connected to another computer, with the last one connected to the first. So as you can see, so it's as a ring. So we have star topology. This is a type of topology. All the computers are connected to a single hub through a cable. See, as you can see, so they have only one switch and then they're connecting more computers. Okay, network protocols and communication. Protocols. Protocols are rules that govern communication, while network protocols describe processes such as the format or structure of the message, the process by which network devices share information about pathway with other networks. So how and when error and system messages are passed between devices and the setup and termination of the data session. So we have organizations such as this is IEEE and IETF, Electrical and Electronic Engineers, and then Internet Engineering Task Force. So commonly used protocol. So we have HTTP, TCP, IP, and multiple protocols. So HTTP, which is Hypertext Transfer Protocol, it is a common protocol that governs interaction between web server and a web client. While Transmission Control Protocol, TCP, the individual conversion between server and clients, and not just web servers and web clients, but also the TCP segregates the HTTP messages into smaller pieces called segments. Internet Work Protocol. So it is used by router in selecting the best path to the destination host. Multiple protocols. The message received by the host usually contain multiple protocols, plus the actual data which application header HTTP may or may not exist. Encapsulation and decapsulation. Encapsulation, this is a process to hide or protect a process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. Also makes one type of network data packet to other data types. And the decapsulation, this is the inverse of the encapsulation process. Encapsulation is the process of wrapping the data, while the decapsulation process is a process of opening packs. Okay, let us move to our packet tracer. Okay, let's proceed. Just hold on. Okay, this is the whole packet tracer. As you can see, I'll give you the example of the packet tracer. So I will put it in the middle. Excuse me. Okay. Okay. These are the packet tracer, and they have PC, laptop, server, printers, and the IP. This is the example. And while we have, this is the switches. Different types of switches. So, and we have router. So they have also different types of routers. So they have model like ISR 43321, and these are the media connection. So this is automatic, and this is the straight line. So which is you can console, and you can connect here and pass internet, and they have cross connection, so you can connect only through switches to router, so you cannot connect it to end devices. So again, they have server. This is the server, and they have many more. This is the security one, emulation. Okay. Okay. Just wait a minute. Okay. Let's move to network models. Wait a minute. Okay. Now the last one, which is this is 3. Okay. The last one, network models. Our objectives are differentiate protocol, model, and a reference model, define the TCP, IP model, and the OSI model. Discuss the function of the layers of the OSI model and TCP, IP models. Compare the OSI models with the TCP models. Okay. Protocol and reference model. Protocol model, this provides a model that is closely equivalent to the structure of a certain protocol. Reference model, this provides a common reference for a maintained consistency within all types of network protocol services. So they have network model defines. So network model is a set of network layers and how they interact. The following are the two most important and well-known network model. So they have OSI model, which is Open System Interconnect, and TCP IP model, Transmission Control Protocol / Internet Protocol. Now this is the OSI model. So they have 7 layers for the OSI model. The first one is physical layer, data layer, network layer, data link, sorry, transport layer, session layer, presentation layer, and application layer. So function of the OSI layers, application layer is the topmost layer of the OSI model. These layers provide a means for the user to interact with the software application. So layer number 6 is presentation layer. This layer provides proper common data format that is sent across application layer surfaces. Excuse me. So we have session layer, layer number 5. So this layer establishes, manages, and terminates connection between application. This layer provides services to the presentation layer. So transport layer, layer 4. This layer defines services to segment, transfer, and reassemble data individual communication between the end devices. And then the third layer is network layer. This layer provides services to exchange the individual pieces of data over the network between identified devices. So layer 2, data link layer. This layer provides methods for exchanging data over a common media. So the last physical layer, layer 1, this layer describes the mechanical, electrical function and procedural means to active mean and the active physical connection for a bit transmission to and from a network device. So we have TCP or IP model. So we have 4 layers: the network access layer, internet layer, transport layer, and application layer. So we have functions of the TCP or IP model layers. So one is application layer. This layer represents data the user plus encoding and dialogue control. So transport layers support the communication between devices, diverse devices across diverse network. Internet layer determine the best part through the network. Network access layer controls the hardware devices and media that makes up the network. So OSI model versus TCP model. So OSI model loss out to us the protocol suite of the internet. The TCP model is mapped to the OSI model. So TCP/IP is the protocol used today, but OSI model is often used to describe network communication. So this is the differentiate of the OSI model to TCP model. Okay, let us make example of different types of topology. Topology. Okay. These are the different types of topology. So we have, as you can see, this is bus topology. So we have connecting two switches and 5 computers. So you can connect from each other. And another one, we have ring topology. So as you can see, they have 5 switches and 5 computers. So you can connect each switches, and that switches you can connect to each other. And another one, the last one, which is this is the star topology. Star topology, so they have only one switches and all of the computers should be connected to the one switches only. Okay, and that's all for today. So thank you very much for our discussion. And also I have to explain about this binary IP address and prefix length, subnet mask, gateway address, and broadcast address. So number 1, my answer is /27 because as you can see, so 255, 255, 255, and 224. So 255, 8 plus 8 plus 8, so 24. So remaining 3 is 128, 64, and 32. If you will add this one, so it's altogether 224. And then the number 2, which is the answer is 172.201.95.255 because the end of this network address should be the broadcast will be end at 255. Number 3, So slash 25. So I will put 255, 255, 255, 24, and 128 is the another plus one subnet mask. So slash 25. And then the number 4, which is 10.10, 0.78129, because the gateway address should be additional only 1 to the end of the IP address. Number 5, so 110000 is 192. 128 plus 64 is 192. I'll give you the calculator. 128 plus 64 is 992. And then 64 plus 16 plus 4 is 84. And 128 plus 64 plus 32 plus 235 plus 8 plus 1 plus 2. It's 235, correct? And then 0. Okay. And then number 6. Again, you have to put 255. 192.84.235.2, this one, 0.255. The 7 one, which is the 2 7, the correct answer is slash, this is not 18. A minute, I will add again. So 24, 128 plus 64. So this is 24 plus 2, it's 26. So I'm sorry, this is 26. Okay, number 8 should be ending with 255 again. So 172.99.187.25. And number 9, which is 205. I'll show you how to get this binary. 205. So 128 plus 64 plus 1 plus 4 plus 8. 128 plus 64 plus 8. Okay, 205. And then so 205. Then 36. So 36. 36 is 32 plus 4. And then 0.72. 64 plus 8. So 72. And then 56, 34. 32 plus 16 plus 4. It's 52 plus, sorry, 8. So 32 plus 16 plus 8. It's 56. And then the last one is 205.36.72.255. And that's all for today. Thank you very much. So I will give you the YouTube link later. Thank you very much.